Okay, in this problem I have a box of mass M2 of 3 kilograms. Make this 3 kilograms. It rests on a frictionless horizontal shelf and is attached to strings. The boxes M1 is 2, M3 is 2.6, and here we want to find, let's find out what the acceleration is going to be, and let's find out what the tensions are going to be. Now the thing to note on this one is, in this case we'll make this T1 and here we'll make this T2. The thing to note here is T1 is not equal to T2 in most cases. It's probably not. So start out with, draw a free body diagram of M1. So come down here, we'll draw a little dot coming down. We'll draw our vectors coming down here, going up here. So we got 19.6 coming down, which is 2 times 9.8 coming down. Just like that. And then we will have T1 coming back up. And at this point, go ahead and write your equation. Summation of forces in the y direction is equal to mass times acceleration. We'll have minus 19.6 plus T1 is equal to the mass of this object, which is 2, times the acceleration. So that's one equation right there. Draw yourself a free body diagram of M2. Come to M2. Draw a little dot. It has a mass of 3 kilograms. So a force here, a force here, a force here, and a force here, in this case here. Okay, so 9.8 times 3. It gives me 29.4 coming down here. The normal force we pushing back up, that's going to be the table. That's going to equal to 29.4. We'll have our T2 here. We have a T1 here. Obviously, in this case, the summation of forces in the y direction is equal to 0. But we'll do our x summation of forces. Summation of forces in the x direction. Again, set that equal to mass times acceleration. And I'll make that T1, sorry. So we got minus T1 plus T2 must equal to the mass of that object, and we said the mass of the object was 3, and we'll do that times 3a. So there's our second equation. Alright, now we'll come back and we'll draw a free body diagram of this one, which is 2.6 kilograms. I'll come down. This is 2.6. Now the thing to note too, it really makes no difference what direction you decide the acceleration is going to go. You can make an assumption. I mean, it's obviously here, you can look here, you got 2, you got 2.6, you can tell the object is going to rotate to the right. However, you don't necessarily have to make that decision, or if the system's so complex you can't determine, just determine which direction you want it to go and be consistent, and you're going to get the right answer. Alright, so we come down here, we'll do 2.6 times 9.8. That's going to give me, what, 25.48 coming down. Do that in black. Hang on a second. We'll have T2 coming this way, and now we do summation of forces in the y direction so that they go to mass times acceleration. We'll get minus 25.48 plus T2 is equal to, and we said this object is going to accelerate down, and we gave that a mass of 2.6, so it's going to be 2.6 negative times a. Alright, now you have 3 equations, you have 3 unknowns. I'll lay these all out, and what I would recommend here, you can either do substitution or you can solve with the matrices. I may just choose to solve with the matrices, so I'm going to rewrite this equation right here as T1. I'm doing black, sorry. Is T1 minus 2a, and I'm moving everything else to the right side, is equal to 19.6. I come to this equation right here, I will have minus T1 plus T2 minus 3a is equal to 0. I'll do the same thing for the last one. I'll have T2 plus 2.6a is equal to 25.48. Okay? At this point, what I would recommend, again, matrices, I'll set up a T1 column, I'll set up a T2 column, I'll set up an acceleration, and I'll set up my values over here. Draw it down like this. T1, I got a 1, I get a 0, I got a minus 2, I get a 19.6 here. Second equation will come down to here. I got a minus 1, I got a 1, I got a minus 3, I got a 0. Third equation, 0, I have a 1, I have a 2.6, I have a 25.48. I'll run that. That is a 3 by 4 matrices. When you solve for that, you will get T1 is equal to 21.15 newtons. T2 is going to equal to 23.47 newtons. And acceleration in this case will be 0.774 meters per second squared. Okay, and that's all you really have to do. Pretty straightforward. Again, you don't have to do matrices. You could substitute back in and get the correct answer. All right.